We're here to calibrate the TB4309 from NI, or National Instrument. First, what we need to do is to set this Siglent digital storage oscilloscope into a Bode plot setting. Now we go to analysis. We go for Bode plot, and that brings up the screen to the Bode plot, or some people call it Bode plot. All right. This setup is also requires a signal generator, which is already hooked up right there. One of them will be used as a source for the signal coming in, going to channel, in which case we're going to be calibrating AI 0, which is the first channel. The second one will be the trigger, which will be hooked up to channel 1 of the oscilloscope. And then the output of this AI0 is hooked up to a cable that is connected to channel 2, which produces the frequency response. And to do this, I have already set up the configuration for the bandwidth, which is up to about 500 kilohertz, 60 hertz to 500 kilohertz. And all we need to do is turn it on by pressing the operations button. That enables the computer inside the oscilloscope to start measuring. Triggers down, signal generator, and it's now being plotted right there. It should produce a curve in which the TB4309 was originally designed for. This is designed with a high-pass filter that has a cutoff around 550 hertz. And as we see, it's starting to plot the frequency response, and also the phase tells you the phase delay and the amplitude of the frequency as it sweeps through the bandwidth that it was originally set for. This setup also works with other filters as well. This enables you to determine whether you have the right cutoff design for the filter that you want it to do, and helps you evaluate whether you need to change the values on the components that you're using. So we can see the minus approximately 2.6 dBm. The 3 dB cutoff is probably somewhere around right there, 500, probably around 550 hertz. It's at minus 2.9 dBm, so pretty much close enough. And so I don't need to tell you guys what the model, because you can see it from the video itself, but this is a cheap cheap setup here if you're interested in measuring the frequency response. This is pretty much like the S21 of a filter. I hope it gives you a little bit of information, may help you set up measuring filters.